EPC, engineering, procurement, and construction contracts are by far the most widely used in the construction of industrial plants. Let's take a closer look at some of its features. EPC projects are divided into the corresponding segments. Engineering, where all the technical documents are developed. Drawings, conceptual, basic, and detailed engineering. Material and services estimation, process details, etc. This is the segment in which all the rest of the activity is based. Procurement. This activity includes the acquisition of products and services, the logistics to bring the materials to the right place and at the right time, and the functions of quality control in the factory and in some cases also on-site. Construction, which includes all physical installation activity, coordination and supervision of workers and subcontractors, quality control of field activities, pre-commission activities, etc. In addition, there are general commercial and technical tasks which affect all segments of the process. Naturally, these are not isolated blocks, but large functions within a project managed under the umbrella of an EPC type of contract. We have already mentioned the importance of perfectly defining the scope of work in an EPC contract. What the Project Management Institute defines as project boundaries. Defining those boundaries implies an explicit identification of the activities that are under the responsibility of the contractor or contractors, and those that are under the direct responsibility of the developer. To this purpose, documents such as division of responsibilities, statement of work, or division of work are prepared. Let's remember that in the project management triangle or iron triangle, scope is one of the three variables that must be kept in balance to achieve an expected quality. Another way to draw the triangle is to put the key variables on the sides instead of the vertices. In this case, the scope is drawn as the base of the triangle. It must be perfectly defined prior to making a reasonable estimate of costs and schedule. To obtain the expected result of the project, each phase requires the definition of the organizational levels through which the project will be developed in its different stages. An important figure is the project manager or the project director. He or she must have the required technical and economical knowledge, accompanied by soft skills such as communication, leadership, conflict management, etc. In general terms, a project organizational chart is the way in which a work team is organized within a project for its execution. It defines the hierarchical relationship and the chart of authority that is established for a given phase of the project. As it may seem obvious, an EPC project requires detailed planning of time, costs, and resources to effectively manage risks during the execution of the project. Planning does not only imply a forecast of the schedule of activities, developed at multiple levels of detail, but also the definition of deliverables, the breakdown of tasks, the use of resources, as well as the expected costs and risks. All companies that execute EPC projects have solid quality management systems. A quality management system is a set of policies, processes, procedures, and resources designed to plan, control, and continuously improve the quality in an organization or project. A quality management system must contemplate both quality control elements and those aimed at quality assurance. Quality control is focused on the product and on carrying out tests to identify potential defects to be corrected. Quality assurance, on the other hand, is focused on processes with the aim of preventing defects proactively. Both functions are essential and complementary to each other. In parallel to quality control and quality assurance tools, a document management system is needed. Such a system helps to maintain complete traceability on all the documents generated and used throughout the life of our project. Before the construction of an industrial plant, engineering studies involving different disciplines are needed, such as those we have already shown as an example of a project organizational chart. Process, piping, mechanical equipment, civil engineering and structures, instrumentation and control, and electricity. Deliverables from engineering will be a huge number of technical documents. Those will be used for resource estimates, for construction, and for the subsequent operation and maintenance stage. This extensive documentation ranges from general process diagrams such as BFDs or detailed ones such as P&IDs to drawings and supplier lists or spare parts manuals. Of course, a document management system is essential to have efficient and effective traceability. This intense engineering activity, the E in EPC contracts, will represent between 5 and 15% of the total cost of the project. Although this proportion seems relatively small, it is crucial to the success of the project. Good engineering reduces acquisition costs, optimizing material selection, construction costs, improving constructability and minimizing changeovers, and subsequent operation and maintenance costs throughout the entire life of the plant. Procurement, that is the P in EPC, consists of the acquisition of goods, services, or works from external suppliers. The purchase must be made at best possible cost, always considering the needs of the purchaser in terms of quality, quantity, time, and location. It is common for companies and organizations to establish processes aimed at promoting fair competition among potential suppliers. In industrial projects, procurement functions typically include cost estimating, purchasing, inspection, and activation processes. In some companies, the functions of invoicing and spare parts management can also be part of this section. Cost estimation can be carried out during the design or construction stages. In particular, the procurement area is responsible for estimating prices, since the estimation of quantities is carried out by the technical disciplines. As already mentioned, there are several cost classes depending on the maturity of the project. The purchases of products, equipment, and materials, as well as the contracting of services, are not based exclusively on price. The concept of total cost of ownership, or TCO, which considers costs of the entire life of the product, is often used. Procurement follows a formal process that starts with the specifications. Suppliers are qualified to be included in a request for quotation. Their bids are technically evaluated and tabulated to determine the one awarded for the contract. Purchase orders are issued based on that signed contract. The inspection function provides quality assurance. It validates compliance with the standards required during the manufacture and construction of the different components. Finally, the activation function promotes the timely delivery of the goods purchased. To this end, it proactively monitors the status of the purchase order during construction and up to the final delivery. The activation team verifies physical quality, delivery times, and the associated technical and regulatory documents. The construction phase, the C on EPC projects, begins in a planning stage, where the scope is reviewed, specifications are defined, and the activity is organized in terms of breakdown, timelines, and resource allocation. Cost estimation and risk assessment with their possible mitigation strategies are also part of this stage. A study of the site is carried out, including location, access roads, orientation, and potential obstacles. Construction tasks often require temporary facilities for intermediate storage, pre-construction activities, and space dedicated to administrative areas, first aid, changing rooms, etc. The construction activity involves civil works, including foundations, assembly of structures, mechanical and electrical systems, instrumentation, etc. This phase ends with some initial tests and the handover for commissioning. It is important to note that a part of the engineering team is usually present as support and consultancy during the construction phase. Once construction is complete, the next steps are commissioning and startup. Commissioning involves the application of engineering techniques and procedures to inspect and test each operational component of the project. From individual functions such as instruments and equipment, to complex equipment such as modules, subsystems, and systems. The main objective of commissioning is to ensure the safe and orderly delivery of the unit, guaranteeing its operability in terms of performance, reliability, safety, and information traceability. Either immediately after startup or just before the end of the warranty period, it is common to carry out a performance test at full load. The objective is to demonstrate the guaranteed production volumes, quality, and specific consumption of materials and energy. Verification of whether the contractual figures are actually met is usually carried out by an independent third party, and it is not only relevant for owners and contractors, but also for operators, investors, and direct clients. Results are used to determine the actual return on investment and to establish contractual penalties or rewards. In a project, transfer means the handover of the system, area, building, or component from the construction phase to the owner, who is responsible for the operation and maintenance of that asset. A set of standard procedures and protocols is used for the transfer, allowing for an orderly startup and smooth transition toward the regular operation and maintenance of the industrial facility. Once the owner has received the plant, it enters the operation and maintenance stage. It is at this point that the client's expectations, as expressed in the original specifications, can be verified against actual performance.